In this session, I want to discuss about characteristics and importance of data structure, and what is data type, what are the types of data types, how the data will be represented, and last one ADT. These will be discussed, and these PPTs are definitely useful for your notes also. So what is data structure? Data structure, I already discussed that it's a way of organizing and managing the data in the memory. Okay, it's a method of collecting and organizing the large amount of data more efficiently. Here the basic thing is efficient management and organizing the data in the memory. And next one, we can design. So any data structure is designed to organize the data to suit a particular purpose. Okay, so the data is using for particular purpose. The data might be for student information, otherwise some array of information, otherwise some string oriented information, even though that can be accessed and worked with a particular appropriate way. Okay, and next one, a data structure may be selected or designed. Why we are selecting this kind of data? To store the data, in the memory with a particular purpose. Okay, already discussed that the data will be stored in the memory with a particular purpose, and of working on it with the various algorithms. Okay, by the data structure also we will discuss some algorithms. Next, what is the characteristics of database? So three things we have to learn, that is correctness, time complexity, space complexity. What is correctness? So here the implementation should be very mandatory. The data structure implementation should be interface correctly. So we should develop nothing but implementation here, nothing but our task is going to be uh, processing, nothing but developing a program. That should be very correctness. Next one, time complexity. So time complexity, nothing but we already did some programs, nothing but C programs. So while we are running that program, otherwise executing the program, so those operations of the data structure must be as small as possible. Okay, so we have to reduce the time. So that is the time complexity, basic. Next, space complexity. What is space complexity? Space, nothing but when we are developing any program, we should reduce the size of our code. At the same time, memory usage of the data structure operation should be little as possible. Okay, so while we are developing any program, memory also should be, we have to use the memory as little as possible. Okay, these are the basic characteristics of a data structure. What are the importance? So what is the data structure here? Maximum all of the softwares and programs are used by these kind of data structure. So, and these data structures are used in almost every program on software. It helps to write the efficient code. By the data structure we can develop a efficient and integrity of developing the program. Okay, next, data can be maintained more easily. So by the data structure we can maintain and understandable, easy to retrieve, at the same time easy to organize, otherwise make any operations on the data. Next, data structure is just a container for the data. Okay, already discussed that array is a collection of data. So array is called one of the container nothing but it will contain the content will be the some similar information of data. Just like data structure is act as a container for the data, and we can use these kind of containers to store, manipulate, some searching, sorting, different kinds of operations will be handled on the our data structure. This is the basics of data structure. And one more thing, we have to know the data structure hierarchy. I already discussed these. I want to show it again. Data structure will be divided into the primitive data structure. One is the non-primitive data structure. What is primitive? So what is primitive? Say that, so already discussed that basic data types. Basic data type, nothing but integer, float, character, and the pointers all will become under the primitive structure. And non-primitive data structures collecting the arrays, lists, and files. So at the same time, we have to know one more thing. That is, I already discussed that data structure will be divided into the two types. One is linear and non-linear. So these non-linear and linear will become under the non-primitive data structure. So we will discuss all this, and so this is the basics of data structure hierarchy. Data structure hierarchy will be divided into two parts. One is primitive. Somebody calls it preemptive. Primitive data structures or non-preemptive data structures. Okay. So before that, what is a data type? What is a data type here? A data type, already we know about the data type. So any kind of data we are going to use for a program, that is declared the particular kind of primitive data types. So these are the basic and default programming data types. So what is a data type? It is a classification of data. So we can classify data. It might be a numerical, float, otherwise it might be character, some double oriented, string oriented, these kind of classification of data which tells the compiler. So it specifies to the compiler what kind of data we are going to use. So for the integer, these many bytes; for the float, these many bytes. It has to defined by the compiler. So the data type specifies the compiler that which kind of data we are going to use and what kind of data bytes will be occupied for the particular data type. Okay, next, most programming language supports the various types of data. So maximum all of what we have used, these kind of integer, float and boolean character, these will be executed and used by the many programming languages. And third one, anything that can be stored the data can be called as a data structure. So we know that a data structure is a container, it holds the different kinds of data. Okay. Next, this hierarchy also given. So what is primitive data structure? Primitive data structure is nothing but these are the basic data structures that directly operates upon the machine instructions. So these already primitive data structures examples, our integer, float, character, these are the primitive data structures. So these are the used to represent the single value. These used to represent the single values and have the different representation in different computers. So sometimes some machines, some programming using the different kinds of representation. So differentiation among the different machines. These are the available in most of the programming languages. Okay, so these are the different examples for the primitive integer, float kind of character. We already discussed in C language. Integer, for it is used to represent a number without decimal. For the float, with a decimal value. Character represents a single character. String for the collection of characters. Boolean for the represents logical, either true or false. True or false. True for the 0 value. False, 1 value. Then go to the non-preemptive data structure. What is non-preemptive? So these are the data structures are more complicated data structures and are derived from the primitive data structures. Even though these are derived from the primitive data structure, even though these are the complicated, so they emphasize on grouping same or different items with the relationship between the each data items. So these kind of data types will be divided into the linear or non-linear data structure. So these are emphasizing on grouping the same or different types of items. So it might be comes under the group of same items or different data items and make the relation between these data items. So data structures will be divided into two types. I said primitive, non-primitive. So in the primitive, I already discussed the basic data types, and non-primitive will comes under the data structures, linear data structures and non-linear. What is linear? So linear and non-linear will be discussed in the second unit. Even though just we will start and just to get an idea about the linear and non-linear. What is linear? Linear data structures traverses the data elements sequentially, just like our arrays. Continuous locations. By the arrays, we can say the array allocation will be done by the continuous locations. At the same time, string also. For the string, it's a collection of characters with the continuous location memory allocations. And in linear data structures, only one data element can be reached directly. It includes just like our arrays, linked list, stack, queues, these data structures. We only know about arrays. In the next sessions, from the second unit, we will learn about linked list, stacks and queues, different kinds of data structures. What about the non-linear? So these are the not continuous locations, not we can get the sequentially. In non-linear data structure, the data values are not arranged in order. So these are not arranged just like continuous locations, and as a data item is connected to several other data items. Just example, so data will be scattered in the memory, so these will be get connected. So after that, these will become say in a one by one data linking. Okay, Next point, it uses the memory efficiently. So while the data will be scattered, even though we don't waste the time and memory also. So memory efficiency will be increases, and free continuous memory is not required. Free continuous memory is not required for allocating the data items. Okay, it includes the trees and graphs. These kinds of nonlinear examples are trees and graphs. Okay, so it will helpful for the memory efficiency. And next, one more thing we have to know, that in the first unit, data representation. What is data? What is data? Basically, we say that data is a some collection of information. What is information? Information that might be a group of some raw information, raw detail information will be collected into the group of data. Okay, what is data representation? How the data will be represented here? Data representation refers to the form in which data is stored, it processed and transformed. So whenever we are given some data to your machine, it will be it might be goes under the storage, it might be for the process and for the transmitted. Suppose we store some information, some file, sometimes we will process, just like while we are doing some programs, and we can transmit it, nothing but we can upload and download, we can transfer the data from one disk to other disk, just like that. So these are the different representations. So what are the different kinds of representations? So decimal number system, binary number system, octal number system, hexa. So decimal nothing but from 0 to 9. So these kinds of values, and just like our numerical values. Binary nothing but by 2, nothing but 0 or 1. Our machine language is the binary language. All the data will be stored in the machine language. Octal 8 from 0 to 7. Hexa 16 0 to 15. So how it will be represented? So how the representation? Our computer is a digital computer. All the data will be stored in the 0 or 1. Okay, it represents by 0 or 1. Okay, next thing, how the data will be representation in the memory. So in the memory, we already know that the data might be represented in a using some array kind of some group of values, Suppose here we have taken some continuous locations. It will be started from 200, some 204, just up to 244. So from 0 to 11, nothing but 12 index here. Okay, nothing but all the data will be stored in a continuous location or address 200, 204, 208 up to the last digit 244. So 44, nothing but, so continuous locations data will be allocated. And one more thing, the data might be stored in the tree fashion. How the data will be tree here? Okay, so data will be represented in the tree fashion. So see, suppose here given some A, B, C, some alphabetical values. These values will be stored in some tree oriented. How will these will be? We will discuss. So these are not located as a continuous locations. The data was scattered with the particular addresses. Some just not like continuous locations. Before we are discussing some 200, 204, 208, but here not the same. So might be 200, 300, some 706, some different kinds of hexadecimal values. So in one more thing, in the data will be represented in the form of graphs. So nothing but one data will be connected to the other data. Suppose here I have show some graph here. Suppose 0, 1, 2, 3, 4. Here 0 is connecting to the some 1 and 4. 4 is connected to 0 and 3. Just like that, all the data may be connected to the other data items. May be connected or may not be connected. So this kind of data we say called as a graph representation. In the tree, it might be just like parent hierarchy, parent children and children's children, just like siblings, just like data will be stored, even though these will be linked together. Okay, so this is the basic representation of data. And one more thing, we have to discuss the last topic, that is the abstract data type. So this is a new concept for you, that is the abstract data type. What is abstraction here? ADD stands for abstract data type. So here ADD is a set of data values, the set of data values and associated operations that are independent of implementation. So while we are using data structure, it is a container to hold the different kinds of data, and a collection of associated operations will be allotted for the particular data. So some collection of data and along with the particular operations. Okay, so these are the IDT. So just we can say that the IDT is a mathematical model with a collection of operations that are defined on the data. Some mathematical operations and might be some sorting, some searchings, different kinds of mathematical model will be discussed. Next, the strength of an ADT is its implementation. So the basic ADT will be developed, understandable in the implementation. So next, what are the different parts of the ADT? One is the declaration of data. So how the data will be used. So the data might be just like that linear data, non-linear data. Okay, so and next what are the different operations upon the data. So different operations, nothing but, so here we are using the different operations that might be some mathematical data operations. Otherwise some I want to insert some data into the data structure, I want to delete some data, I want to check out nothing but I want to display all the elements in the data, and I want to make searching. Otherwise I want to sort the particular data values in the data structure. Otherwise I want to match the data. So as two data collection of data will be there, I want to make those two group of data values. Otherwise I want to do some other kind of any mathematical operations. So these are the different kinds of operations we will develop on the abstract data type. What is the ADT? Is nothing but it's a collection of data along with the associated operations. The operations might be any kind of operations. So basically we have the data in the data structure and we make the some operations on the data. So basically just introduction about the ADT stands for it's a collection of data and we have to declare some operations upon the data. Suppose in the arrays we will discuss, in the array we can insert the data, otherwise we can sort the data, we can search a particular element in the array of elements, otherwise we can do the some just like array uh, array multiplication, array addition, array subtraction, this kind of different kinds of operations upon the database. So this is the basic representation and what is the ADT. So in this session I have given a clear idea about how the data will be represented. Before section I have discussed what is data structure, types of data structure. In this session I have discussed about how the data will be represented. That is the new concept here, how the data will be represented. So the data might be represented like different models, just like continuous location, how the data will be location just like arrays might be in the tree fashion, just like parent child, child's children, just like that, and it might be stored in the graph fashion. And one more thing, ADT already discussed with the particular data in the data structure, making some operations upon the database. These are the basics. And so basically we have to say that a data structure is a container, otherwise making some organizing. So how the data will be stored in the data structures. And one more thing, we have to know the primitive and non-primitive. In this section, in this unit, we only discuss the data structure introduction. Next, algorithms and programs principles and its complexity. These will be we will discuss. And from the next unit, we will discuss the types of data structure. That is linked list, stack, queues, graphs. All these will be come from the second unit. Okay, this is the second session.